The solution for 1982 number 1. The first meters of a 100-meter dash are covered in 2 seconds by a sprinter who starts from rest and accelerates with a constant acceleration. The remaining 90 meters are run with the same velocity the sprinter had after 2 seconds. So that should say the first 10 meters. The first 10 meters is what that should say. Determine the sprinter's constant acceleration during the first 2 seconds. So during the first 2 seconds, the sprinter is going to start with no velocity. Then the velocity is going to increase. And for the remaining 90 meters, the velocity remains constant. So that means for the first couple seconds, the acceleration is not 0, but then is 0 for the remaining 90 meters. This is the part that part A is asking us to solve to determine the sprinter's constant acceleration during the first 2 seconds. So we would use our strategy X, V initial, V, A, and T. So X would be 10 meters. V initial would be 0 meters per second. The final velocity we don't know yet, and acceleration we don't know yet. The time we do know is 2 seconds. So let's underline the 3 things that we know, and the 1 thing that we're looking for, which is the acceleration. So that equation will have to be X is equal to X initial plus V initial T plus 1/2 AT squared. Since he's starting or she's starting with no initial position, that's going to be 0. And the same with no initial velocity, that'll be 0. So we can solve this equation for acceleration, which would look like this. The acceleration would be 2x over t squared. So 2 times 10 meters divided by 2 seconds, and squaring that would give us a value of 5 meters per second squared as acceleration. So we know that that's the acceleration there. So part B asks us to determine the velocity after 2 seconds have elapsed. So now in this case, we know the acceleration, the time, the initial velocity, and the final position. We're just looking for the final velocity. So our final velocity equation, or the equation we could use is V equals V initial plus AT. And in that case, since again we know the initial velocity is 0 meters per second, and the acceleration is 5 meters per second squared, which we solved in the previous part, and we know that the time is 2 seconds, the final velocity after those 10 meters will be 10 meters per second. Question C says, determine the total time needed to run the full 100 meters. Well, the first part, the part where they're accelerating, we know that that part will take 2 seconds. So we know, let me use a different colored pen here. So we know that this part here, that part will take 2 seconds. The question is, how long will this part take? The remaining 90 meters. Well, once again, we could go to our strategy of X, V initial, V, A, and T. We know that the acceleration for that part is 0 based off our motion map. No acceleration. We know the initial velocity there, because we figure that out in this part, is going to be 10 meters per second. And so is the final velocity, 10 meters per second. The distance is 90 meters. So that means we use this equation, X is equal to X initial plus V initial T plus 1/2 AT squared. But because acceleration is 0, that term goes away. The initial position is 0. And because initial and final velocities are the same, that really becomes x is equal to vt. And to solve for the time, we would say that's x divided by v. The x distance is 90 meters. The velocity is 10 meters per second. It never changes. The initial and the final are the same. So we get a time there of 9 seconds. So we know that this part is 9 seconds. We know that the first part is 2 seconds for a total of 11 seconds. Then the remaining of question D asks, on the axis below, draw the displacement versus time curve for the sprinter. So we know that in the first 2 seconds that the displacement is 10 meters. So, okay, but we know it's got a positive acceleration. We know there's a positive acceleration because there's our value for the positive acceleration. So this part has to be an upward opening parabola. All right. Then at that point, it takes the runner a total of 11 seconds to run the race. So the final point would be there, and the part where the velocity remains constant would start right here. And so we've got to draw a linear graph for that point. So this part here would be parabolic, upward opening parabola. Again, the reason for that is that there's a positive acceleration. And right here, this part would be linear. And again, that is because the acceleration is equal to 0.